R.2. Talk about absolute value a little bit, and not so much absolute value graphs, but absolute value as an equation type situation, or an operation actually. So absolute value, what is it? Anybody know? I think we all know what it does, but all right, fill in the blank, gang. Absolute value is the blank from blank. Thank you. Very good. Distance from zero. Okay. So an absolute value is a distance, how far a number is away from zero. That means it's a measurement. Measurements are never negative in distance. Okay. When you measure a distance, distance is always positive. Direction can be negative, but distance is always adding up. If you ever watched Ferris Bueller's Day Off, they can't roll the odometer back by running the car in the reverse. It still runs up the mile. Okay, so distance is always measured in positive. So answers to problems like this, the absolute value of 3, how far is 3 away from 0? 3 units. The absolute value of negative 3, how far is negative 3 away from 0? Still 3 units away from 0. Still a positive distance out of that. Where they throw a little curveball into it is they'll put a negative out there in front of the absolute value and then throw a number in there. And you've got to think order of operations here. Order of operations with absolute value. Absolute value ranks at the same level as parentheses because it's a grouping symbol, just like brackets or parentheses would be. So you do the absolute value first, and then what's really out in front of those that symbol? It's like a -1 is there. So what's the absolute value of 5? It's 5. And then you're saying -1 times 5, which is -5. So there is a case where we had a problem that's got an absolute value in it, but the answer ends up being negative because of the negative on the outside. Biggest confusion would be when they do something like this. They put a negative inside of the absolute value and then a negative on the outside of the absolute value. Now, what does that answer give us? -6. So you do that. Absolute value -6 is 6, and then that negative on the outside makes it back to -6. Okay, so be careful of that. Very simple idea there to start off with. And then the next thing would be to evaluate some expressions for x equals -6 and y equal to 10. So they're going to give us some expressions with variables in them, such as this, absolute value of 2x minus 3y, and say, evaluate that for x equals -6 and y equals 10. What do we do with the -6 and the 10? Plug them in. 2 times -6, 3 times 10, and then we're going to take the absolute value after we're done. So do the work. 2 times -6, -12, minus 30, still inside the absolute value, and then -12 minus 30, -42, inside the absolute value. Now we can do the absolute value of that, which is 42. The order of operations still rules the roost in any math situation. Same values for x and y. Much more complicated problem, but not too terribly difficult to perform this problem. Plug in x and y. So x is -6, y is 10. So I'm plugging in 2 times absolute value of -6 minus 3 times 10 in absolute value over -6 times 10 in absolute value. So I'd work the numerator, then I'd work the denominator separately and simplify from there. So the absolute value of -6, 6. 2 times 6 is 12. 30, absolute value of that is 30. and then absolute value of negative 60 is 60. So I just got to simplify from there. Negative 18 over 60, which is going to reduce. I know 6 goes into 60 and 6 goes into 18. So negative 3 over 10, which is all the way reduced. Know that. Just plug it in and follow an order of operations. Parentheses, exponents, multiplication, division left to right, and addition, subtraction left to right. So follow those order of operations. If you don't, it won't work out to be correct most times. Say all the time, but most times. Okay. So absolute value, easy stuff, right? Let's drop into the second section already. Yeehaw. 1.8. So dropping from a review chapter in your textbook to the first chapter, which is absolute value equations and inequalities. Absolute value equations and inequalities. We're going to start with equations and work our way up to inequalities. Equations are easier. If we had the absolute value of some number is equal to 6, what are the possible numbers that could be? It could be 6 or it could be negative 6. X is by itself with both of those equations. So we're done. Okay. It gets a little more interesting when they throw something in there like x plus 3 is equal to 6. So with this one, it's telling me that some number plus 3 has an absolute value of 6. So it's not quite as easy to mentally think of that, but it's pretty easy to set up the equations. On the first problem, we took whatever was in the absolute value, x, and set it equal to positive 6. Then we take that same x and we set it equal to negative 6. It's going to be do the same thing here. We're just going to take x plus 3, set it equal to positive 6, and then set it equal to negative 6. We've got two equations to solve. We didn't have to do anything on example A because x was already by itself. Nothing to do. We're going to take both of those equations. X plus 3 equals positive 6, and x plus 3 equals negative 6. The absolute value part has to be by itself before we can do that. We'll come into contact with some problems where it's not that way. But here it is. So we set whatever's inside of that equal to the positive and the negative, and then solve each of them separately. Subtract 3. There's x equals positive 3. Then when I subtract 3 over here, I get not negative 3, I get negative 9. It is, if there is anything else inside of the absolute value marks here that's added or subtracted, you won't get the same number, positive and negative. The only time you get the same number, positive and negative, is if that is just like x or like 3x or something multiplied times x. That's the only time you get the same answer, just one positive, one negative. The rest of the time you should be getting different numbers on the solving of those equations. So don't kind of get into the most common thing I see with folks in absolute value equations is they'll just do this first one and then they'll say the other answer is negative 3 without even showing any work or anything like that. So don't get into that problem that occurs. Okay. So here, a very similar problem, just a little bit more complicated. You got an absolute value that has nothing else on the outside of it, and it's equal to 10. So we're going to set up two equations. 2x minus 7 equals positive 10, and 2x minus 7 equals negative 10. Solve each of them separately. Plus 7. 2x equals 17. Divide by 2. X is equal to 17 over 2. The other one, do the same steps. We're going to get a much different answer. That's negative 3 divided by 2, negative 3 over 2. Notice they're different numbers, but they both would satisfy the original problem. We plug those in for x. 17 over 2 times 2 is 17. 17 minus 7 is positive 10. The absolute value of positive 10 is 10. I plug in negative 3 over 2. Negative 3 over 2 times the 2 is negative 3. Negative 3 minus 7 is negative 10. The absolute value of negative 10 is also 10. So you get two answers that both work in your original problem. 6 minus 4x in absolute value is equal to 14. Okay. Is the absolute value by itself? There's nothing on the outside of it, is what I'm asking. Yeah, it's ready to work. So we're going to set up our two equations. What are our two equations? Yeah, 6 minus 4x on both of them. One's positive 14, one's negative 14. Then we solve those separately. 14 minus 6 be 8. And then divide by negative 4. Negative 2 for one of them. Same steps for the other one. Much different answer. So it's negative 20 divided by negative 4. That'd be positive 5. Both solutions to that original absolute value equation. Easy stuff. Lot easier lifting today than it was last week, I think. First day of class, pretty heavy stuff. Look at this one. Absolute value of 2x plus 8 minus 6 is equal to 16. So here we're getting into that. Why does he keep asking, why is the absolute value by itself? Well, here it's not. So we need to get the absolute value by itself before we do the problem. So how do I get the absolute value by itself? Yeah, add the 6 to the 16. Now the absolute value is by itself. And I can set up my two equations, right? 2x plus 8, 22. 2x plus 8, negative 22. Solve. The 14. And then divide by 2. 7. Same steps over here. Different answer. 30 divided by 2. Negative 15. Not too bad. It's pretty easy stuff. Just gotta keep in mind a few simple solving equations deals. All right, so let's throw this at you. 2/3 absolute value of x minus 5 plus 4 is equal to 7. Okay. It's absolute value by itself. Absolutely not. That's a bunch of junk on that one. Let's get rid of it. What do I do first? Subtract 4. We do need to move the 4 before we move the 2/3 because it's not directly attached to the absolute value. So we're going to move that 4 first. So we're getting the like terms together. So there's 3. 2/3 absolute value of x minus 5. How do I get rid of 2/3? Divide by 2/3, or I'm going to multiply by the reciprocal. I'm doing that. Solving equations. Dividing by 2/3 is the same thing. If you do that with the calculator, be careful that when you're dividing 3 by 2/3, you put the 2/3 in parentheses. It's 4.5. I'm gonna hit math, enter to get that in fraction form. Okay. If you don't, if you just do the division like this, that is not the same answer. Obviously, 4.5 and 0.5 don't give you the same thing. So be very careful if you're going to do division that you put what you're dividing by, if it's a fraction, in parentheses. If you don't do that, it's going to give you an incorrect answer. So here the absolute value of x minus 5 is equal to 9/2. Even though that's a fraction, we still set up two equations here. X minus 5 is equal to positive 9/2, and x minus 5 is equal to negative 9/2. And solve those. One steppers. 9/2 plus 10/2 would be 19/2. You can use a calculator for that. I don't care. Doesn't bother me. It's just my high school class would be different. I'm mean to them. I'm not mean to you. And then negative 9/2 plus positive 10/2 would be 1/2. That's right answers. Yeah, that's right answers. Those would work in the way back to the original. That's about as complicated as they get with the equations. They don't get much more difficult. They're not going to have one where you got an absolute value on both sides. You just have absolute value on one side with this. Okay. There are some kind of specialty absolute value equations that you've got to look out for. And that would be one like this, where you have the absolute value, maybe like x plus 17 is equal to -3. And this goes back to the fundamental definition of absolute value. Absolute value is a what? Distance from 0, and distance is always what? Positive. How in the world could a distance of x plus 17 be negative? It can't. This is the easiest one. It's no solution. Anytime you get that absolute value by itself and you got a negative number on the other side, that's a no solution. Because remember, distance can't be negative. Distance is always positive. Okay. Dylan told us it's a distance away from 0, so that's got to be a positive number. Okay. H. Don't jump the gun and decide too soon. So, like if we had this problem, -3, absolute value of x plus 6 plus 10 is equal to 6. Right now, it looks like it's got a solution, but I can't decide yet. Never decide if it's no solution until you get what by itself? The absolute value. So right now, what do we need to move to get that to happen? The 3 and the 10. Which one do I need to move first? The 10, because it's a like term with the 6. I'm going to subtract 10. And there I have -3, absolute value of x plus 6 is equal to -4. Is that a no solution? Can't tell yet. The absolute value is not by itself yet, right? So we can't make that decision. What do we have to do now? Divide by -3. When I divide -4 by -3, what does that turn into? A positive answer. Oh, so it is one I've got to work. Got to get an answer for. So I get absolute value of x plus 6 equal to positive 4/3. Then I split that into my two equations because it does have answers. If that were a negative fraction, then it wouldn't have answers. There'd be no solution. But it's positive now because the negative divided by negative. So I'm going to take that and set them up. Every time I say that, I always think about, anybody know the song, Set 'em Up, Joe, and Play Walking the Floor? If you don't know that song, it's a good song. You should YouTube it and see what you think. Buddy Cannon song way back when. But anyway, set up your equations, solve them. 4/3 minus 18/3. And you can do that with a calculator. I'm fine with that. 4/3 minus 6. And just to get you, 4/3 minus 6. Mine's gonna throw the answer back as a decimal. I'm gonna hit math, enter, and that'll change it back into a fraction for me. -14/3. And then subtract 6. And that's going to be -22/3. We get two answers for that. They work in the original. Okay. So there's your exceptional one on example G, where if it's an absolute value symbol with X inside and you've got it equal to a negative number, that's a no solution. But you can't decide that until the absolute value is by itself. So be very careful of that. Okay. So that's absolute value equations. In the title of the section, it also had inequalities. Inequalities are very similar in how they work, but there are some rules about what kind of solutions we get based on what inequality symbol we have to start with, okay? So, with inequalities, you've got the absolute value stuff. Got X, we'll just do like X plus 7. If it's a less than any number over here, we'll just do 9. If it's a less than, it's going to be an and problem. If it's a less than or equal to, it's an and problem. If it's a greater than, these are ands, X plus 7 greater than, that's an or problem, okay? Absolute value inequalities are compound inequalities. They're either going to be and or problems. And the way that I teach knowing the difference is the saying land of Gore. Okay. Land of Gore. In the land of Gore, less thans are ands and greater thans are ors. My wife has a whole long, like page-long poem that she spits at them. Sometimes she does it to a beat, sometimes not. I don't have that kind of rhythm, so I won't do it to a beat. But it's the land of Gore. That saying, less thans are ands, greater thans are ors. That's what you got to remember. If it's a less than symbol, less than or equal to, or just plain less than, it's an and problem. If it's a greater than symbol, it's an or problem. Land of Gore. Less than, that's an and problem. Greater than, it's an or problem. Okay. Now, less than symbol, remember, is that, and there's the one with equal to sign. Greater than looks like this. The absolute value needs to be on the left to decide that. I'm 99.97% sure every one of them you see in your textbook, and I'm 100% sure the ones you see on your Canvas quiz, the absolute value is already on the left. If for any reason you see one, the absolute value is not on the left, you need to swap it around so that it is. And it's just turn everything around to do that. So, land of Gore, know that, live that, breathe that in your life with absolute value inequalities. Not that you'll ever see that at the grocery store, but you're going to see it next week on your test. We're going to work a few problems like that. All right. So example I think is right. H was the last one, maybe. Yeah. Here's our absolute value problem. Absolute value of 2x minus 5 is greater than 7. Okay. Absolute value is by itself, and it's on the left, so we're good to go. Is this an and or an or problem? Or. This right here tells us this is an OR problem. So that means we're going to set up two inequalities separately as an OR problem. So we're going to set up 2x minus 5 is greater than 7, or 2x minus 5 is less than negative 7. You flip it and change the sign for the second one. Okay, flip it and change that sign right here. Flip that symbol, change that sign. Then solve each of them. 2x greater than 12. Then divide by 2. X is greater than 6. Or find the answer on the other one. Add 5. That's nice. Negative 2. Divide by 2. And x is less than negative 1. But those together are our solution. We want to be able to graph that on a number line, not a coordinate plane, but on a number line. Okay, so got to review that kind of thing. So number line looks like that. I just got to make sure I've got enough room to get a 6 and a negative 1 on there. So I'm going to, negative 2, or let's do negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6, 7, 8. I'm just going a little bit past each one on both ends. Just takes a little bit of spatial sense and starting somewhere. Okay. Now, got to remember some things about graphing inequalities here. If it's x is greater than 6, then we're going to go to 6 and we're going to put a parenthesis across that, and it's going greater than, so we're going to open that parenthesis in this direction. And then all the numbers that are greater than 6 are this way. Like 7 and 8 are bigger than 6, so we're going to go that way. Notice, what is that pointing? That less than symbol is pointing to the right, correct? That's kind of a shortcut to knowing that. Okay? X is greater than 6 should be going this way. X is less than negative 1. So less than. So we're going to use a parenthesis, but it's going to open that way because it's less than. Okay? And then those numbers that are less than negative 1, negative 2 is less than that. Negative 3 on the way down to negative infinity. There's the graph of the inequality answer. Okay? The interval notation, got to do that too. Negative infinity up to negative 1, parentheses, union, 6 to positive infinity. If you can get the number line done, the interval notation is super easy. Because it's almost just copying that. OR problems will always go opposite directions. OR starts with O, opposite starts with O. They'll always go opposite directions. Always. Okay? We'll do another one. Let's do absolute value of 3x minus 8 is less than or equal to 10. Yikes. So less than. It's what kind of problem? It's an and problem. And problems, in my opinion, are easier because there's just one inequality to solve. So when you set that up, you're going to set it up 3x minus 8 is less than or equal to 10. Then you're going to go back here to the left-hand side. You're going to put another less than or equal to sign and then put your negative 10 down there. You're going to and problems. I call this setting it up like a sandwich. And which. With the word and in sandwich, right? So that's the way I call it, setting it up like a sandwich. And problems can be set up like sandwiches, or problems cannot. Okay. All right. Now, How do we get x by itself in the middle? Get the 8 out. So if I add 8 in the middle, I got to add 8 to the positive 10 on this end, but I also got to add 8 to the negative 10 on that end. So that's going to give me negative 2. It's less than or equal to 3x. It's less than or equal to 18. And then how do I get x by itself in this? Divide everything by 3. That's just going to be the fraction negative 2/3 less than or equal to x less than or equal to 6. There's my inequality solution. X is by itself in the middle. That's what we want. Now I want to graph that on a number line. I'm going to be a little more lenient here because we got, not too pretty of a thing. I got a fraction mixed with a regular number. I think I can estimate where negative 2/3 is on the number line if I just go by integers there. That'd make it pretty easy. 7, 6, 5, 4, 3, 2, 1, 0, negative 1. Okay. Negative 2/3 is not quite to negative 1. It's between 0 and negative 1. 2/3 of the way. Right there. We'll put a bracket there. Why am I using a bracket? Because it's got an equal to mark, right? And I'm opening it toward the 6. Because the and problems, the answers are in the middle. Just like x is in the middle of our inequality. Go to the 6. Bracket there. Answers. All these numbers in between. Now that makes it super easy for the interval notation because you just start with a bracket, negative 2/3, comma, 6, bracket. And there's the interval notation for that. Set notation in purple, graph, interval notation in red. Being able to bounce between all of those, okay? Now, let's look at another one. Let's say we had absolute value of 2 minus 5x is greater than or equal to 4. I lied to you guys earlier. The last examples proof that I did. Sorry. Let's do this. Is that an and or an or problem? It's an or problem. Okay. How do we set it up? There you go. Solve each of those. Start with this one. Be 2. And then I divide by negative 5. What happens when you divide by a negative? Flip the sign. So it's going to be less than or equal to negative 2/5. Or let's go ahead and do some work here. Negative 5. X less than or equal to negative 6. Divide by negative 5. And again, you flip the symbol. And negative divided by negative becomes positive. Now, we've got an OR problem. We want to graph it on the number line. And this one is nice because we got fractions in both of them and they have the same denominator. So that makes it a little easier to actually use fractions on your number line instead of whole numbers. Because then you don't have to estimate you don't estimate 2. You get exactly what you're looking for. So on the number line, I'm going to use the trick of changing the numerator and not the denominator. So if I use 7 over 5, 6 over 5, 5 over 5, 4 over 5, 3 over 5, 2 over 5, 1 over 5, 0 over 5, negative 1 over 5, and there's negative 2 over 5. Amazing. And then it counts down. You know, and you could simplify any of those fractions that worked out through there that, you know, actually this is 1, and this is actually 0. I'm not going to be too picky about that. Where you got to draw it, you're going to see some graphs already drawn for you. And sometimes they do it this way. All right, so bracket or parenthesis on the negative 2/5. Going which direction? To the left. Okay, so bracket, left. On the 6 over 5. Bracket to the right. Easy enough. What's our interval notation? There you go. Good job. Kate. All right. Questions about absolute value inequalities. All right, I told you earlier that they weren't going to put an absolute value on both sides. I lied to you. I'm going to show you one of those and let you see what you need to do. It's actually not that difficult if you do get that. So let's say you had absolute value of 4x minus 3 equals absolute value of x plus 6. I'm doing an equation here. Now, they won't do an inequality with an absolute value on both sides. That is very sketchy. Okay, so inequalities, you won't see that. But with an equation, you might see 1, maybe 2. So easy thing about this is it's an equation. So you're going to set up 2 equations. One of them is going to be take the absolute value marks off. Just like that. The other equation is going to be take the absolute value marks off and then change the sign of one of the sides. I'm going to change the sign of the x plus 6 side. So I'm just going to make it negative and then that whole side. What that's going to do is just change the sign of the x and of the 6 and make them like that. Okay. And then you just solve them like regular. You know, nothing's different about how you do it. Plus 3, 4x equals x plus 9, subtract x, that's 3x equals 9, divide by 3, x is 3, and then do the same thing over here, just, you know, a different answer. That's 4x equals negative x minus 3. Then you add x. That's 5x equals negative 3. And then divide by the 5. Negative 3/5. So having an absolute value on both sides really doesn't make it that much more difficult. You just got to remember to change the sign of everybody on one of the sides to solve them, and then it works out real nice out of that. Pretty easy set of sections tonight. Believe it or not, that's it. Page 18, 83 through 88, and then 91 through 98 is good ones. And then 1.8, 153, 1 through 65, something like that would be some good ones to look at to get you prepped for your Canvas quiz. Will be available tonight, should be available right now. And then I'll post the lecture online, and also